Well, welcome to this online revision session for AQA D1, in which we will be looking at the June 2010 question 4 on route inspection. Well, you can see in this question we have 13 towns. The time to travel between each pair of towns is indicated on the edges, and we're also told that the total time is 384 minutes. Part A, we've got to use Dijkstra's algorithm, starting from M to find the minimum travel time to each of the other towns. So the key thing here is to indicate clearly that we are using Dijkstra's algorithm. So we're starting from M, so from M to M is 0, so we can box in a 0 at the beginning. And then we know that from M to J would then be 6, M to K is 12, and M to L is 9. We now box in the smallest of those values and then calculate the travel times from M through J to H, which would be 21. J going round to E, which would be 46. And then from J to K would be 11. So that would reduce our time to K down to 11. We can now look again at the smallest of these values, which would be the 9. So we'll box in this value. And then L to G would give you a temporary label of 49 on here. L going through I would give you a temporary label of 20 at I. And L going back to K would give you an answer of 15, but that's not less than 11, so that wouldn't change anything there. We can now box in the 11, because that's the smallest of all the temporary labels that we have on the diagram. And then 11 and 8 makes 19, which of course is less than the 20 at I, so that now becomes 19. K going up to F would give us 11 and 22, which would give us 33. And 11 and 9 would make 20, so again the temporary label at H would be reduced by 1. Again we look for the smallest of these temporary labels, which is the 19. So we can box in the 19. And then we have 19 and 20 makes 39, so that reduces the label at G to 39. 19 and 13 makes 32, so that reduces the label at F to 32. Looking at our temporary labels then, 20 is now the smallest of those at H, so we can box this one in. And then 20 and 11 makes 31, so this one is now reduced to 31. And 20 and 20 is 40, which reduces the 46 to 40. Once again, we can look at the temporary labels that we now have at E, F and G. The one at G is the smallest, so we can box this one in. 30 and 10 makes 39 and 10 will make 49, or have I missed? Sorry, I've boxed in the wrong one, my apologies. I should have boxed in the 31 first. That was the smallest of 39 and 31 and 40. So 31 and 19 makes a temporary label at C of 50. 31 and 6 makes a temporary label at D, 37. And 31 and 50 makes a temporary label at A of 50. Now remembering that the 39 is not boxed, 37 is now the smallest number, so I can box in the 37. And 37 and 11 makes a temporary label for 48 now at C. D plus 12 makes 49 at B, and 37 plus 13 still makes that 50 at A. Well, now the smallest of our labels would be the 39. 39 and 10 does not give you less than 48, so the 48 stays at C. Similarly, I can now box in E as being 40, and then 40 and 20 makes 60, so that's no better. 40 goes up to A, which is 47, so that reduces that label to 47. That's now the smallest of what we've got left, so I can now box in the 47. I can then box in the 48, and finally I can box in the 49 at the top. Okay, so how do we get the marks allocated? There are 7 marks. If we've got cancelling at least 2 of the vertices, like we have at E and H or F, then that will give us a method mark of 1 to start off with. For having the correct values at K, the 12 and then the boxed 11 will give you an answer mark. If you've got 3 values at F, that will give you a mark. You've got 2 values at E or G, that will give you a mark. If you've got 2 values at A or C, that will also give you a mark. And then if everything is all completely correct, including the final values in the vertices boxed, that will give you a full mark. And then finally, if you've got 49 for the value at B, that gives you a final mark. So there we've got the 7 values that are allocated. Okay. Right. Let's see what the next part of the question asks you to do. Well, in part B, we're on to the Chinese postman problem, finding the travelling time of the optimum Chinese postman problem around the network, starting and finishing at M. Well, you can see at M we have an odd vertex. So the key thing to do to start with is to list the odd vertices. So we've got M, we've got A, we've got C, and we've got B. Now what we need to do is consider all the possible pairings, of these odd vertices. So for example, we can do A to B and M to C. Or we can do A to C and M to B. Or we can do A to M and B to C. So if we now find the distances for each of those, we can see that if we do A to B, well, the shortest distance there is going to be 25. And then we've got to add the M to C distance. Well, on our previous diagram we can see the shortest distance from M to C is 48. And so that will give us a total for that pairing of 73. Similarly, if we do A to C, Well, the shortest distance from A to C is 24, and the shortest distance from M to B, we look back on our diagram, was 49. So if we add those together, that's also 73. Finally, we've got to do A to M. Well, the shortest distance back on this diagram was 47. And from B to C, the shortest distance is 23. And so that gives us an answer of 70. So, we know that to travel round all of these edges, the total distance that were given at the beginning of the question was 384. But two edges have got to be repeated, and the two connections have got to be repeated, and we can see that the one that would be the minimum would be to go from A to M and B to C. And we know that the shortest distance, the one that we would add in from B to C, that distance is 23. And from A to M, wherever it goes, through the network, adds in 47. So the total with the additional edges that have to be travelled would be 384 and 70, giving us a total of 454. So this would be the minimum, or the optimum travel time. That part of the question, we've got 6 marks. So how do we get those 6 marks? Well, if we've used the correct odd nodes, the A, B, C and M, I've stated them, that'll give you 1 mark if that's implied. For then having 3 correct sets of lettered pairs would give you a method mark, and then for having 3 correct answers to those totals would give you 2 marks. If you've only got 2 correct out of 3, you'd only get 1 mark. And then for adding the minimum of those to the 387 would give you 1 mark, and for coming up with the correct value would give you the final 6 mark for that part of the question. It then says, state the number of times that vertices F would appear in the corresponding route. So in other words, if we travelled round from M, travelling through the route between each of these places, remembering we've got to repeat the B, D, C part to make B an appropriate odd node and C an odd node, and we've got to repeat the journey to A starting from M. And so we know at F at the moment we've got 1, 2, 3, 4, 5, 6. So 6 divided by 2 means we're going to visit F 3 times. Question is, when we draw in the extra 1, that is going to mean, or extra 2, if we're going through that way, that may or may not add an extra route. So if we look through here, we can see that to get to A from the 47, we actually came along the 19 because the shortest route to F from M was 31, and so the shortest route from M to A actually goes from M to J to K, then up to H, then across to F, and then up to A. So when we do that additional route from M to A, we actually travel through F for an additional time. So that will mean the total number of times that we visit F will actually be 4 times. So we visit vertices F 4 times altogether. And for stating that value, you will get 1 mark. Well, hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.